everyone. Today's lesson is about nuclear chemistry. Now, nuclear, as its name implies, has to do with the study of the nucleus. So the subatomic particles that are found in the nucleus are protons and neutrons. Sometimes we refer to them as nucleons because they're particles that comprise the nucleus. And so when we talk about nuclear chemistry, we're studying and discussing the interactions between protons and neutrons, and we're talking about them in the context of, where they are in the nucleus. So we're going to be using the reference table as always, and we'll be referring to tables N and O in order to help us understand the different facets of nuclear chemistry as we study the nucleus and the interactions between protons and neutrons. We're going to talk about the words radioactive and stability and what that all means within the greater context of nuclear chemistry. So let's get started. You already know about atomic isotopes, right? So this is just a review. We're talking about isotopes, which are atoms of the same element, but they have different mass numbers. For example, I have carbon-12 and carbon-14 here. Now, they have the same atomic number. That is to say, they have the same number of protons. We know that carbon-12 is 6 because if you look at your periodic table, carbon's atomic number is always 6, which means carbon-14 also has an atomic number of 6. But they do have these two very different numbers, which we refer to as mass numbers, right? So we're saying that carbon-12 has a mass number of 12 and carbon-14 has a mass number of 14. So what's different then? And I think you already know the answer to that, but I'll give you a second to tell me. Great job. It's the number of neutrons. So if we were to look at a picture or a different representation, right, you can see here that both carbons have an atomic number of 6, but over here the mass number is 12, and over here the mass number is 14. So why do they have these two different atomic masses? And the answer is, well, they have different numbers of neutrons, which you already know and you've probably already told me. And so 6 plus 6 gives us a mass number of 12, and 6 plus 8 gives us a mass number, or if you prefer to call it, an atomic mass of 14. We know that there are 8 neutrons here and 6 neutrons here. So these carbons are isotopes of each other, meaning they have a different number of neutrons, but they do have the same number of protons. So now we're going to talk about radioactive isotopes, or sometimes you can combine that word radioactive and isotope into one word, radioisotope. And whenever I mention the word radioactive, I'm going to be telling you something about the stability of an atom's nucleus. If the atom's nucleus is radioactive, that means that it's unstable and it's going to be breaking apart somehow. And we're going to talk all about that in future videos. And so here we have these isotopes that are not stable and they're undergoing nuclear decay. Now, you've already heard the word decay in many contexts, but decay means breaking down, right? And so you have nuclear decay where the nucleus is breaking down. If the nucleus is decaying, it's radioactive. So you can call it a radioactive isotope, or you could refer to it as a radioisotope. The way that you can tell if an atom is going to break down or not, right, if it's stable or unstable, is that an atom has to have a very specific ratio of neutrons to protons. And that's what's going to determine how stable the nucleus is. Approximately an equal number of protons and neutrons is stable. However, you'll notice as the atomic number increases, there are going to tend to be a larger amount of neutrons. And so when you have an atom with an unstable nucleus, it's called a radioisotope and it emits radiation. That makes sense, right? It's going to be decaying, so it's got to be emitting or giving off some type of radiation when it degrades, which again is just a fancy way of saying decay or breakdown. So we have these radioisotopes, these radioactive isotopes, meaning they have different numbers of protons and neutrons, and certain ones might not be so stable because of their ratio of neutrons to protons, and they're going to be breaking down and emitting radiation. Here's a graph that we call the band of stability. Here's the atomic number here on the x-axis. Here are the number of neutrons here on the y-axis. Remember, atomic number really just tells us the number of protons. So this is the number of protons, the number of neutrons. This solid black line is a 1-to-1 ratio. So you'll see it's very close to a 1-to-1 ratio of protons to neutrons. And here are all of the different stable isotopes of all of the atoms. And you'll notice as it goes up, it tends to need to gain a little more number of neutrons in order for it to be stable. But for the most part, if it's found in what we call right here, anywhere you see any of these dots, the band of stability, then it is going to be a stable isotope and most likely won't really be breaking down too much because it's stable. The opposite of being stable might be if it falls outside of the band of stability, in which case it would be unstable, and we could expect it to break down and emit and decay. So it would emit some type of radio particle, something that it's going to be giving off. And just for future reference, any elements with an atomic number greater than 83 is going to have no stable isotope. So any element with an atomic number greater than 83 is not stable at all. That means any element above 83, 84 and on is going to be radioactive and emitting some type of particle while it breaks down. And so the last slide that I'll leave you with today is the idea and definition of radioactivity. In radioactivity, the nucleus of an unstable isotope is going to be decaying spontaneously. So all of a sudden, it's just giving off these rays and particles. There's nothing that we're doing, no activation energy. It's decaying spontaneously because it's unstable, and this decay will allow it to reach stability. Now, here are all of the different particles and rays that will be or can be emitted in nuclear chemistry when you have a radioactive isotope or radioisotope. And so if you look, just like when we look at the periodic table, right, the top number is going to represent the mass of the particle, whereas the bottom number will represent the charge. So an alpha particle will have a mass of 4, a charge of 2, and it could use this symbol He because helium's atomic number is 2, so it represents that alpha particle, or you could even use the alpha symbol, which would represent it. We've got beta particles, similar to electrons. They're high energy electrons. They have a mass of 0 and a charge of -1, or you might see that symbol beta. Then you've got gamma radiation, which is just a lot of energy. No mass, no charge, lots of energy. You're already familiar with neutrons and protons, which brings us down here to a positron. And a positron has a mass of 0, but a charge of +1. Very similar to the beta particle, except it's got a positive charge, mass of 0, charge of +1. Still can get the symbol beta, it's just going to be opposite. So these are all of the different particles that we're going to be talking about in our next video, and that will give us an idea of all of the different ways that different elements can decay in order to stop being radioactive and reach some type of stability. They're going to have to decay and emit these particles and rays, give them off so that their nuclei, right, so that the nucleus can reach stability, because we know when it's radioactive, it's unstable. So that's the idea for today. That's what we're talking about. Nuclear having to do with the nucleus. These particles are going to be radioactive. They're going to be decaying spontaneously, emitting different rays and particles. We've talked about the possibility of emitting an alpha particle or a beta particle or a gamma particle or a positron, and that will be our conversation next time. But today we have to know radioactive, unstable isotopes that are unstable we call radioisotopes, and that has to do with these nuclei being radioactive. So we're going to be studying the interactions and behaviors of our protons and neutrons, which are found in the nucleus, as we talk about radioactive and radioisotopes.